I just had a wonderful conversation with Emanuele from Dusk Network. And we did not just talk about Dusk Network, which is a general purpose but fully privacy preserving L1 blockchain. We also talked about his very personal story, how he got into space, and what avionics and sensor solutions for airplanes have to do with blockchains. It's a quite interesting story, and I learned a lot here. And finally, we talked about what's coming up for Dusk, what's happening in the next 12 months, and specifically some alpha leak for all of you for what is going to be going on Dusk and who's using Dusk and what use cases specifically. So if you're interested in that, or if you're interested in some of the behind the scenes of snarks, starks, bulletproofs, and plonks or other proof systems, then check out this episode. Welcome everybody to our series of Web3 talks. I'm very delighted to have a fellow privacy enthusiast with us here today. I welcome Emanuele from Dusk Network. Hi, Emanuele.
Hey, nice to be here.
Thanks for joining us here. And yeah, let's talk a little bit about Web3, about privacy. And maybe for context, before we dive into some of the details of it, tell us a little bit about your personal story, and then let's get into Dusk. Like, how did you join this crazy Web3 space? And yeah, what was your story?
Well, my story begins quite a long time ago, because I am an engineer with more than 20 years of experience in development, and I was drawn to the space. I was drawn to the so-called Byzantine fault-tolerant systems already back in 1999, because in avionics, where I started, whenever you have sensors that are malfunctioning, they can be modeled as Byzantine actors, meaning actors or adversaries that start to provide different answers to different entities that ask for their data. And I was always drawn to this problem, because it's an incredibly hard problem to solve. And in fact, in avionics, it is solved by exchanging a ridiculous amount of messages to make sure that all the different sensors are synchronized. They have the same kind of view of all the data, regardless whether a sensor is working or not. But it is still a very, very hard problem to solve. And then fast forward in 2009, I heard that somebody solved these problems, solved the Byzantine fault-tolerant problem, by exchanging just one message. And I was blown away, and then that is how I discovered the Bitcoin white paper. And Bitcoin is a Byzantine fault-tolerant system that achieves synchronization among the network by using game theory, and discovering that you could tackle a completely different problem using a solution domain, which doesn't really belong to the problem domain. A Byzantine problem is a networking problem, whereas game theory tackles the economic system, right? And that fascinated me, and that is how I, started to get more and more involved. I realized that it's not really a suitable solution for sensor networks, because sensors don't really care about maximizing one profit. So the mining, the proof of work and mining algorithm wouldn't really work to, solve the Byzantine problem in avionics, but certainly does for a hell of a lot of different other configurations or networks out there, financial networks primarily. This is how I got interested into the overall decentralization, and to have a decentralized network that could use game theoretical systems or game theoretical knowledge to solve the synchronization problems. And then fast forward another 7 or 8 years.
Give me a second here before we get into Dusk. Let me see if I got this right. So basically, you worked in avionics, which is like impressive to hear somebody apply problems or solutions from avionics to like crypto. But basically, the problem is like, I guess you have a bunch of sensors in an airplane that determine, I don't know, maybe the speed or the altitude of the airplane. And you want to make sure that all these sensors have a common view of the system, in that case, I guess the airplane. And, they have to synchronize somehow that, not one of them is realizing, okay, we're going forward, and the other one is saying, no, we are still grounded, right?
That is correct. Essentially, you want to achieve a consensus on the overall status of a system, whether the system is, the orientation of an airplane, or whether the system is, a ledger or the mutations that happen on a ledger. That's practically an abstraction of these two systems. And when you have Byzantine actors in the system,
maybe for our listeners here, what does Byzantine actors mean? Like what?
It is a technical term that identifies a participant in the network. In the case of avionics, a sensor. In the case of a financial network, can be a node of this network that simply provides different messages to different parties. So, for example, if I tell you, if I am a thermometer, and when I'm asked the temperature, I say it is 12 degrees Celsius. And then to another node in the network, which asks me at the same time, I say it is 11 degrees Celsius, then I am a Byzantine actor. And malfunctioning sensors, they are normally modeled as Byzantine. Whereas on a financial network, another example could be, I have 3 different transactions, A, B, and C. And to another node that is asking me, I have only 2 transactions, which is A and B. And this is how you model a Byzantine actor in different kind of networks. And the interesting thing is that in order to achieve consensus among all the different actors about how many transactions have been processed or how many transactions are finalized, then you have different ways of doing it. Either you use what is called the Nakamoto consensus. So you mine a block, you elect a leader using proof of work, for example, and that leader decides what are the transactions to be included in the block, and then sends the block to everyone together with the solution to a small cryptographic puzzle to convince everyone that he is the leader of that round. In the avionics, where this is not possible, then the only other mean that you have to keep everybody on track is to exchange an amount of messages which is normally exponential in the amount of actors or in the amount of sensors that need to exchange these messages. So one is very efficient, the Nakamoto consensus, and the other one is very inefficient, the message exchange. And that is how I got into the in 2 completely different domains, how I got interested in Byzantine fault tolerant systems.
Nice. It's very interesting to hear how you can really apply similar lessons learned to a very different domain. Now, tell us a bit. So again, to me, it's wonderful to see Bitcoin as the foundation, as this very pure and first mover in this space that really was a wake-up call, I guess, to many of us. I guess to me in a similar way. Yeah, take us forward from there. How did you get from there to Dusk, and what is Dusk trying to achieve?
Yes, so a long has been passed since I first have been reading the Bitcoin white paper, which I believe it was around 2011, something like that, when I first heard of it.
Oh wow, you were in very early. That was a very wild time.
Yeah, well, I was aware of it also because at that time I was the director of research and development at TomTom, and it was my job also to dabble with any kind of technology or technological advancement out there. So I remember that one of my colleagues and friend recommended the white paper to me, and I began to read it, and I was already quite hooked into the overall system. I didn't really buy Bitcoin back then, but the same friend in 2014, he made me aware of another project that was very interesting. And considering that, he and we have a history of positively influencing each other, then I listened to him very well. The project was Ethereum. So this friend of mine, he participated in the ICO of Ethereum. And then, but since then, I didn't, but since then I actually started to track the project quite closely. And the capability of, going from programmable money, so to speak, to programmable transactions, and the idea of having a virtual machine and smart contracts deployed on the virtual machine that essentially are programs that are unstoppable in nature and do not need oversight or intermediation. That was absolutely flabbergasting and very, very inspiring. And so much that I knew immediately that I wanted to work in the space. I wanted to fulfill this vision, or to help fulfilling this vision of disintermediating processes. And this is how I, at some point, I had the idea for Dusk Network, because I saw one requirement that was left unfulfilled by Ethereum or any other smart contract platform out there, which was privacy. And so at the end of 2017, then after researching the field for quite some time, I created the foundation of what then became Dusk Network. I created the white paper, and I started to lay out the architecture of the overall platform.
That's very interesting to see that you basically saw kind of this Ethereum as this big machine, that had a lot of capabilities, but it was missing privacy that you set in to bring. Well, if I remember correctly, back then we did already have some privacy coins, I guess, right? Was Monero or Zcash around at the time already?
Yeah. Both were around. Essentially, we had three different approaches to privacy. One was the one highlighted by the CryptoNote paper, and then it evolved into into all the different CryptoNote based chains like Monero or even like Zcash. As a matter of fact, Zcash, before becoming Zcash, I think there was a lot of experimenting with what was called back in the days Zero Coin, that had the capability, or that theorized the capability of using an accumulator to prove or to burn coins and to mint them in a way that would break the link between a sender of a certain transaction and the transaction itself, so the coins that were sent. But from a practical perspective, there were at that time only two main ways to provide privacy to transactions in a decentralized fashion. One was the snark way, and the other was the bulletproof proof system. There was a third one, which started just around in 2018, which is the Stark, proof system. But it wasn't really very well researched. It was just starting by then. And what I immediately saw was that there were a lot of problems with all these different proof systems. So
could you maybe, before we get into the specifics, could you maybe, and this is a difficult question for a not super mathematical audience, just give like a high level overview of these three different approaches that you mentioned, and kind of like what differentiates them maybe from one another?
Yes. So it's difficult to do it in a non-mathematical way, but I will try to be quite generic. So essentially, when you are dealing with zero knowledge algorithms, zero-knowledge algorithms are a set of different algorithms that were theorized and implemented in an interactive way already in the 80s by Micali, Goldschaffer, and don't remember the third one, through a paper that was created in the 80s. And there weren't really many practical applications for zero-knowledge technology until there was a way to use them in a non-interactive way using what is called the Fiat-Shamir heuristic. So zero-knowledge tools essentially allows in a certain trustless context to prove certain mathematical statements and to disallow from a verifier to learn anything other than that statement is true. So to give you a very stupid example, if I want to transact together with you, and I want to send you some coins, and I want them to be obfuscated so that the verifier doesn't really see the amount of the coins that I am transacting, then I need also to convince this verifier that I am transacting, for example, a positive amount of coin. Because if the verifier would accept a transaction with a negative amount of coin, then basically what I am doing is I am depleting my recipient's wallet. And there are three different flavors of zero-knowledge proof characteristic. One is called snark, and is based on is the one that was used by Zcash first, and then it evolved into different kind of protocol. Snark is a proof system that requires a trusted setup. So the creation of a context that is common between all the different participants in the network. And the trusted setup is called the trusted setup because essentially participants to the network need to trust that at least one of the participants that created this setup was honest. And if this isn't the case, then the SRS, which is the string or this context, this common context that is created through this trusted setup, can be used in order to forge proofs. And this is incredibly dangerous because if you can forge proof, then, like I said, I can forge a proof that convinces a verifier that the coin that I am sending are positive, while in fact they are negative. And
so it does not only allow for, is it correct that it does not only allow for de-anonymization, but it also allows you to kind of break the integrity of the ledger?
More than anonymization, is more about creating or forge proofs to convince a verifier about statements that in fact are not respected in the transaction. So, for example, I can create a proof that I am spending coins that I do own, while in fact in the transaction I am spending coins that I do not own, or even I can create coins out of thin air. I can mint them.
Okay, so you can literally double spend. You can make up like
you can do a lot of nasty stuff, and the danger of that is that it's this kind of operations would be even very, very difficult to detect. There couldn't be any detection, for example, of a malevolent inflation of a certain protocol in case, for example, the trusted setup didn't even see one honest participant. That is one of the problems of snarks back in the days. Another problem of snarks, but this has been solved with the newer proof system, is the fact that it is quite specific to what you want to prove. So say, for example, that you have a smart contract, like in Dusk, in Dusk case. We cannot foresee all the different configurations of that smart contract. So it would be very impractical to, create a trusted setup for every single configuration that we do allow on that particular smart contract. So this is why we started with bulletproofs, because bulletproofs does not need a trusted setup. It, in fact, uses a trustless setup. And it would have been probably also feasible for us to use Stark back then. But the problem with bulletproofs is the fact that bulletproof creates proof which are quite bulky in size, and they are verified very slowly by the verifiers. So the verifiers the proof can be verified in a time which is linear in the amount of gates, or the amount of constraints, meaning that if you want to prove, or if you want to verify proofs of statements that are very complicated, it takes a significant amount more time than verifying proofs that are not really that complicated. And since you deal with smart contracts, then you have no idea about the complexity of the proof that needs to be verified.
That's the difference between like stuff like Zcash or kind of Turing complete, I guess EVM like settings, right, where you can execute a whole lot of different things.
Not exactly. So it is the difference between different proof systems. So Zcash, a snark proof is normally very concise, it's very succinct, and it's verified in constant time. And normally the verification takes 5 milliseconds. Bulletproofs instead will be verified in a time that depends on the complexity of the statement, and also the proof is very bulky. Stark is the bulkiest, but the verification time is slightly better than bulletproof, but still, if I'm not mistaken, linear or sublinear in the amount of gates. So for a network that does proof or uses zero-knowledge proof every once in a while, let's say only for doing rollups, then using Stark, for example, is perfectly acceptable. Using bulletproof is perfectly acceptable. Nobody does that anymore. But why? Because essentially you try to do rollups once every blue moon, once every epoch, let's say. And so what you do is you take a bunch of transactions, you aggregate this transaction, you create a proof, and it doesn't really matter if this proof is verified in hundreds of milliseconds or it is very bulky. It is something that happens only every so often. But in case of Dusk, considering that we have the only confidential smart contract, layer 1 confidential smart contract out there, then we need to add a zero-knowledge proof per transaction, because all our transactions are confidential. So we need to, and this means that having a proof that is slow to verify, this would constrain our TPS, our transaction per second. So
sorry, which proof system do you use in the end at Dusk?
And we use Plonk, which is an evolution.
We have a fourth one coming
of a snark of a snark system, so it's very, very, very fast. We also, in order to be even faster, then we created our own zero-knowledge friendly hashing algorithm, starting with Poseidon, and lately we also created reinforced concrete, aka Zelbet, which are very, very fast zero-knowledge friendly hashing algorithm. And so Plonk can be used, we use Plonk, and this provides us sufficient performance to have quite a fast network.
Okay, good. And so the capabilities for the people who might not be familiar with Dusk at all, like tell us about the capabilities of Dusk.
Well, Dusk is the only blockchain that I know of which provides confidential smart contracts, and smart contracts that basically provide the capability of accessing or carrying zero knowledge proof. Not only that, this is how we remain private. We do that for a reason, though. It's not that privacy is, that we do privacy to be private. We do privacy because we want to disintermediate the financial system, right? And the financial system requires privacy. Regulation for regulated assets, they do require privacy. And we have also seen that lately, even non-regulated assets like crypto utility will at some point be required to just KYC themselves when hitting an exchange. And this means that when you have a wallet that does a transaction and you have KYC, then you have a strong link between somebody and his own wallet. This is personal data by definition. And because it is personal data, then in legislations like Europe, it falls under the GDPR regulation. Now, and this is going to be a disaster for any kind of open ledger, a decentralized ledger, because GDPR requires you to delete data if the user says so, if the user asks so. And on a censorship-resistant ledger, such as Ethereum, such as Avalanche, such as Phantom, this is impossible. So yeah, it is going to be a very interesting requirement to fulfill from all these chains as soon as the regulators will actually ask them to be KYC'd when operating and when transacting with an exchange. This requirement is fulfilled if you have a privacy-oriented ledger. Why? Because if you have a privacy-oriented ledger where transactors are anonymous, albeit regulated through KYCs that can be carried through zero-knowledge proof, for example, then there is no compliance required from the GDPR, because there is no link whatsoever between an identity and a wallet or a transaction. There is anonymity, and therefore there is no direct fulfillment of the GDPR, which is needed. So privacy is a force of good. It is something that needs to be there most of the time. But it is also great for to fit other kind of regulations. It's great for traditional finance, because you do need, sometimes you don't want to manipulate the market, or you do not want to, trigger certain actions in the market just because you withdrew hundreds of millions of dollars worth of assets from an exchange. You do not want these kind of things to leak from a ledger which is open, and there are many other use cases in the regulated finance that have got to do with privacy.
So Manu, what I hear from you is actually a somewhat different motivation than for what I many times here in the crypto space for privacy. Many times privacy in the crypto space comes from this crypto anarchist angle. But what you're talking about is about including compliant financial transactions. Do I get this right, or what's your driver for building Dusk?
Well, it is two-pronged, I would say. I cannot deny that I am fascinated by the crypto anarchist movement, considering that I do thrive and I do operate in this kind of field myself, and which was heavily influenced by the cypherpunk movement. So, and I am a libertarian. But I would say that in our case, privacy, I mean, I would have loved to, just be able to introduce privacy at a different stage of our network. It is not a mystery which Dusk has been in development for quite some time, for 4 years before being able to launch a testnet. And the reason for it is that we were really the only one taking privacy as in layer 1, and starting with protocols that couldn't really give us what we wanted. We had many different just changes in direction. We changed even the proof system. We migrated from bulletproofs to Plonk. We actually spearheaded the research of Plonk together with Adstack back in 2019. So, and we did that because it is demanded by regulations. Our mission at Dusk is to empower users to gain complete control of the assets that they own. Now, if their assets are regulated assets, then the only way for them to just trade or participate in the financial market with these assets, to issue these assets, to exit these assets, would be to use a trusted third party to provide privacy in case the ledger would be open. And this goes against our mission because we want users to be able to exert absolute control over the assets that they own. And owning an asset means also to be able to carry out these administrative steps. And the regulators do demand privacy through a lot of different forms of regulations. So while from a philosophical perspective, I am very much in favor of privacy, I consider it an absolute foundational right of every human beings. It is also true that we needed to provide privacy from a practical perspective to, fulfill our vision for the market.
Cool. I'm very happy to hear that nuanced view on privacy in a Web3 era. Finally, tell us a little bit what's coming up for Dusk in the next 12 months. You mentioned there's been a lot of really deep technical challenges that you guys have been facing and solving, which is amazing. What's coming up next?
All right. So right now we are working on our testnet. We recently implemented a 3-week release cycle that is going to manage more or less the release of all the different components of the network. From a technical perspective, we are very much looking forward to migrate to the second version of our virtual machine, which is going to give us much more efficiency in how we deal with the state. From a research perspective, we have very, very exciting development in the field of recursive proof. And this is something that is going to make waves in I believe, not only in the blockchain space, but also in the cryptographic realm as a whole. And we are working on this technological advancement. I would say that from a business perspective, there are different kind of pilots and some use cases that we want to work on first. So to immediately showcase how Dusk can be used in order to bridge what is the regulated finance with the crypto DeFi unregulated one, and how we are bringing a suite of different products in order to bridge this kind of gap. And this is what we are going to be focusing on with accelerating everything that will realize our vision for clearance and settlement of any kind of different asset on chain, whether it is with traditional finance or not. We want to roll out our so-called Reg DeFi proposition. And I believe that it is definitely possible for us to do that in the incoming 12 months. And it is certainly something that is going to be immediately evident with mainnet, but even before with the incentivized part of our testnet and with the commencement of some of the pilots which I have been introducing.
Okay. Any specific use cases or names that you want to drop as an alpha leak here, or everything in the making under the hoods?
I would love to do that. I will give you one little Easter egg. I would say Easter has been just passed, so I'm still in context. There is one thing that we are working before the others, and which in parallel with all the different kind of components, and we are discussing among us, and we are probably about to give it priority, which is the capability of doing on-ramp crypto to traditional finance. And that is something that requires the implementation of a digital currency that we hope that can be used together with MTFs, and that we can showcase that it can be used in order to onboard crypto investors on regulated entities. And I think that this is way more than probably I would be even allowed to.
Wonderful. No, thanks for sharing that, because I think it's very interesting for people to feel, what's coming up. On a timeline perspective. Cool. Let's wrap up with any short recommendations for people that you have that might want to look at joining the Web3 space, people who look at your successful career over the long time that you spent here. Any recommendations that you would give them?
I would say that there are many platforms out there that are actually very, very interesting. And I would, apart from, just exploring Dusk Network, which, takes a little bit of a different approach, it's probably the only one that I know of that, focuses on the regulated decentralized finance. But I would suggest for anyone to get accustomed to DeFi, so decentralized finance, using established protocols out there. I am personally very impressed and a big proponent of Aave. I really like that platform. I also do like Curve, and once gaining a little bit of knowledge about money market fund and this kind of interesting lending platform, then sky's the limit. There are many different different use cases and different applications that are very interesting. Another one that I actually love, but this is probably for the more technically minded, is the creation of flash loans, which do not even exist outside of the crypto space. These are loans that are taken, so a borrowing that happens and repaid within the same kind of block. And that is something that cannot even happen on traditional finance because there is no concept of block of transaction being processed altogether. So this is where I would suggest anyone approaching this field look at this money market fund competitor in a decentralized way, and new things that can be done on crypto that cannot be done on traditional finance.
Wonderful. Great. Last recommendations from Emanuele from Dusk. Thank you so much. We ended with a shout out for some great European projects, Aave and Curve. And of course, again, recommendation for everybody to check out Dusk, what is going on, what is coming up, and what will happen over the next 12 months. Thank you so much, Emanuele, for joining us and these super interesting insights here.
Pleasure. Thank you very much for having me, and I'm looking forward to our next one.